The three key ideas in this unit are that the squares and square roots are opposites. The square finds area, the square root finds side length, and thirdly, with Pythagoras' theorem relates square area. It's about the squares. Okay, the three squares are connected to each other. They're related by a squared plus b squared add up to c squared. So when we talk about perfect squares and square roots, it's good to know your perfect squares and square roots. So the first five perfect squares are going to be 1, 4, 9, 16, 25, which means then that the perfect square roots are going to be square root 1 is 1, square root 4 is 2, square root 9 is 3, square root 16 is 4, and square root 25 is 5. And squaring gives us area. So if I start with side length and I square, I'm going to get area. And if I start with area and I square root, I get side length. So when we do these operations, when we do these calculations, when we have 6 squared, we're talking about a side length of 6, and 6 squared is going to give me the area. So there's 6 by 6, so my area is going to be 36. That is a perfect square. 10 squared, again, means that we have a side length of 10. When we're squaring, we're using the side length of 10. And we're going to have a 10 by 10 square, which gives us an area of 100 squares. When we talk about square root, we're doing the opposite. We're starting with area. So we have a square again. The area is 49. The square root is going to give us side length. So the side length of a 49 square is side length 7. Square root 64 means again that inside the square root represents area. And so we have an area of 64. To get 64 squares in here, this is a perfect square, so we can line up all the squares in here nicely. And we're going to get an 8 by 8 square. That means the square root of 64 is going to be 8. And we want to be able to do those perfect square ones without a calculator. For the non-perfect squares, we need a calculator. So the square root of 22 is going to give us the side length of that 22 square. So we can't fit 22 squares nicely in a grid in this square here, but we can make a square that has a side length of 4.69. So when I square root, I'm going to square root 22, and that square root of 22 gives me 4.69. And what that tells me is that the side length of that square is 4.69. And since we have units, we're going to say centimeters. So there's 80 squares in there. Again, I can't actually make a nice grid of 80 squares. That won't work. But we can make a square with 80 squares. It's a non-perfect square. And to find the side length, I square root. So when I square root 89, so square root 89 is going to give me a side length of just under 9. So I get 8 point, oops, so that's not going to be square root 8. Square root 89 is going to be just over 9. So we get 9.433. So I'm just going to round that to 43 centimeters. So this side length here is 9.43 centimeters. Here these ones we can you'll be expected to just type these into a calculator if we want to find the square root of 15. Again, we have an area of 15 squares, and by square rooting, we're going to calculate the length of the edge or the side length, and my calculator gives me 3.87. Again, make sure you can do these on your own. So type this into your calculator yourself. So square root 240. Okay, make sure you've done that. And the answer you should be getting from your calculator is 15.491, which we're going to round to 15.49.